Alright guys, the last thing I'm going to talk about is trig limits. And right off the bat, I'm going to write two at the top. We got the limit as x approaches 0 of sine x over x equals 1. And the limit as x approaches 0 of 1 minus cosine x over x equals 0. And I put these in a box. We're going to keep coming back to these two limits. So I've kind of been holding off on trig this whole time just to kind of introduce it all together. So we're going to do a couple trig limits because calculus has a lot of trig in it. So first example, limit as x approaches 0 of tangent over x. Okay, so again, we'll try the same approach, plugging in. Tangent of 0 is 0, and we get 0 over 0. We get an indeterminate form. So let's try to rearrange tangent over x so that we can find the limit. So we got limit as x approaches 0. We know that tangent of x equals sine of x over cosine x, all over x. Okay, so now we can put this x next to cosine of x and rewrite this as the limit as x approaches 0, sine of x over x times cosine of x. And put the quotations here for the limit so we can hurry up and do this. I'm going to break this up in a way that I can use these shortcuts up here. One of the two. So we got sine of x over x times cosine x. If we split it up the right way, we can use this case right here. So I'm going to try to get sine of x over x times something else. So I'm going to do sine of x over x times 1 over cosine x. Okay, so now we have limit as x approaches 0, sine x over x and there's a limit law that says that you can take the limit of each of these factors separately. So we got the limit as x approaches 0 of sine x over x times the limit of as x approaches 0 of 1 over cosine x. So from the shortcut we have 1. And from plugging in here, we have cosine of 0. Cosine of 0 is 1. 1 over 1 is 1. So we have 1 times 1. So the limit as x approaches 0 of tangent x over x equals 1. We'll do another example. So now we got the limit as x approaches 0 of sine x times 1 minus cosine x all over x squared. Okay, so we have two trig functions here, and we have two shortcuts. We know that one shortcut is sine x over x equals 1. We have a sine of x, and we have an x down here. The other case is nicely put right into this function here too. So we got 1 minus cosine x over x as x approaches 0 equals 0. So we're going to try to use these cases in this limit. Before that, you could even try if it works out. Let's see. Sine of 0 is 0. 1 minus cosine of 0. Cosine of 0 is 1. 1 minus 1 is 0. So we get 0 over 0. So you can clearly see that we're going to have to rearrange this to find the limit. And I'm going to try to use these two cases. So I'm going to go ahead and rewrite limit as x approaches 0. I'm going to take out a sine of x over x. Sine of x over x. And what I have left is a 1 minus cosine x over x. So again, I can take the limit of these two separately to get the limit as x approaches 0, sine x over x, times the limit as x approaches 0 of 1 minus cosine x over x. And again, these special cases help us out. The limit as x approaches 0 of sine of x over x is 1. And as x approaches 0, 1 minus cosine of x over x is 0. So the limit equals 0. Okay, so last example. Last example is the limit as x approaches 0 of sine 2x over sine 3x. Okay, so if we plugged in, we get sine of 0, 0 over 0. Another thing you see right away is we don't have this nice case up here. We can't use it right away. But what if we try multiplying both the numerator and the denominator by a factor of 1 over x? So you can put sine of 2x over x and sine of 3x over x. I'm going to go ahead and try that. Let's go to 0, sine 2x over sine 3x times, in the top, 1 over x, and in the bottom, 1 over x. So what we're doing is just multiplying by 1. I'm going to simplify it. Limit to 0, sine of 2x over x all over sine of 3x over x. So what we did was multiply by 1 over x in the top and the bottom, so that now sine of 2x over x and sine of 3x over x both look like our special case up here. And what I left out up until this point is the limit. This special case can be generalized as the limit as x approaches 0 of sine of a x, any number next to x, over x equals that number a. So in these two cases, the limit as x approaches 0 of sine 2x over x would be 2. And the limit as sine of 3x over x would be 3. So our limit is 2 over 3.